What's up, everybody? It's Miss Wesley. I was thinking we could take a look at some of these review questions on Indefinite Integrals Review 2 as you guys are getting ready for your test, or your quiz, I should say, on indefinite integrals, which is coming up soon. So for starters, let's look at number 2. Remember, disclaimer, it's still me and I'm still left-handed. I still cover up most of the writing that happens up on this projector, but just know that you can pause any of these videos as we go if there's something that I'm covering up. Okay, I'm ready to look at number 2. I think this one's pretty good, and we got to just look at each term and make it easy for ourselves to integrate. Starting with the first term, let's remember our exponent rules. You want to integrate. Well, how do I write this as x to a certain power? The rule is the bottom number of this fraction is going to be what type of root it is. It's x to the 5 is the power you raise it to over 3. Just another way of writing the cube root of x to the 5th. Next term, what would be the best way to write this? Well, generally in class, you guys help me with bringing it up to the top and writing it to a negative power. It'll be easier to integrate that way. This guy's a trick question. You could write it as 2x to the negative 1, and that would not be wrong. I'll write it like that. But honestly, I think we need to watch out for this term because he might have his own special rule when it comes time to integrate. And then what are you doing there? Pi? I guess we just leave it. Minus pi, all that integrated with respect to x. Now here's the step where we drop the integral notation because we're actually going to take the indefinite integral. Go up a power. It needs to be x. If I add 1 to 5/3, I should get what? 8/3, right? And I want to divide by 8/3 out front according to the integration rule. So let's put it as 3/8. Next term. Okay, so let's be smart about this. We want to take it up to x to the negative 3rd. And we want to divide by negative 3. So minus 1 over negative 3. That should become positive eventually. Aha, we've made it to this term. If I tried to use the normal power rule for integration, I would have a big problem. I'd have to be dividing by 0 because that's 1 power higher than negative 1. So this one has its own separate rule. Derivative of 1 over x gets to be ln of x. And you know absolute values need to go around that x, whether it's on paper, in WebAssign, however you write that answer. It's the natural log of the absolute value of x, since this is defined for all real numbers x besides 0, and this is only defined for the non-negatives, and not 0 either. Okay, what about pi? Pi, if it were a derivative, I would say eat the pie. It goes away. This is an antiderivative, so it's a constant, and it gets 1 power of the variable. So in this problem, we'll put pi x. Watch out for some of these questions to be in terms of s or y or t, and then an s or a y or a t would be tagged onto that constant. And then I think I've remembered everything. This middle term should become positive. And maybe you're already thinking of something I've forgotten. Let's see. So 3/8 x to the 8/3 plus 1/3 x to the negative 3 minus 2 ln, and we remember the absolute value of x, minus pi x. And some of you are probably screaming at your computers, Miss Wesley, don't forget the plus c, because all of these are indefinite integrals. So that would be a tragedy if we forget one of those. And that helps with something like number 2. That was a pretty good review question. You're going to see some trig antiderivatives. Don't let these scare you off since you'll have access to those trig antiderivatives. You can just look them up. And I know this one, I'll just look it up on my list. I'll say I'll leave the constant. Think of a function whose antiderivative is secant tangent. And on the list, that would just be secant of x. And then don't forget your plus c. With later questions, a question like 6, I would recommend you simplify first before you keep going. So don't take an integral first. We don't have a product rule for integration. So you're going to distribute in and use your exponent rules. Here's where I add the powers. So x to the 1/4 plus 5/4, I'm up to 6/4 or 3/2. And then minus 4 x to the 1/4. That's where you start the problem. Now's the time to integrate, and be careful with the fractions, right? We'll take this up a power to x to the, if I add 1 to this, 5/2, as long as we divide by 5/2 out front, multiply by 2/5. And then the 4 is going to stay. 1 higher than 1/4 is 5/4, as long as we divide by 5/4. So we multiply by the reciprocal, 4/5. And then plus c. So the first term looks fine. We'll rewrite it. The second term needs to be simplified so we can multiply those 4s up top. And then the last part is that plus c at the end. Love it. Okay. When you get to some of these trig ones, they're great challenge questions. Try to find yourself an identity, a trig identity within the problem. So for instance, number 8 is kind of tough. 8 could be split up into a couple parts. You could leave the 5. Then you could write this, since I've got these identities at the top, and one of them says that cotangent is cosine over sine. I see that in this problem. I could write this as cosine over sine, and I split off that other sign that was in the denominator, so I'll write it as separately a 1 over sine. This is cotangent. Right here, I guess you can't see that. This is cotangent, and this is cosecant. So it's like integrating 5 cotangent of x, cosecant of x with respect to x. I'm looking straight to my trig antiderivatives for this one, and I know there's a rule that says that the antiderivative of cotangent cosecant negative would have been cosecant of x. The rule looks like this. Integral of cotangent x cosecant x equals negative, and we'll say cosecant of x plus c. So use that here, but there's a 5 out front. We'll make this one negative 5 cosecant of x plus c. I think that ones like 7 and 8 are a little bit too tricky to be of the level of the ones that you'll see on the quiz. These are good as challenge questions, and once you have it split up into this version, it's a little easier to see what that one's going to be. I wanted to try 2 on the back. Can you guys flip over? I was liking the looks of both 9 and 10, and maybe we could at least try one of them, especially because I'm going to star this guy, this term here, the natural log of 3. We got to talk about that. We've seen it once or twice pop up in class. Can you start with some stuff that should be manageable? 10x to the negative 1. I can't use the normal power rule. That would take me up to a division by 0. So leave the 10. Look to the rules, right? This is going to be ln of the absolute value of x, would be the derivative of that power of x. E to the x, love it. It is its own derivative. It is its own antiderivative. That stays. Sine of x is negative. Its antiderivative is going to be positive, cosine of x. And then last but certainly not least, ln of 3 kind of fools you. Natural log of 3 has no x in it. It has no variable. It's just a constant. We're going to tag an x onto it. We'll put plus x ln 3. Be careful when typing this into WebAssign or on the quiz. You want to make sure that you didn't write this like ln of 3x. That would be incorrect. You could write it as ln of 3 in parentheses x, that would be fine. Or this might be the safest way to bring the x out front. When you go to try a problem like number 10, I would suggest one of 2 things. Either split it into 2 parts, divide both parts by x, or you could swing up an x to the negative first power. So x to the negative 1 times x, I'll say to the first, e to the x plus 1, taken with respect to x. Okay, you ready for it? Let's distribute in. You've got the integral of x, well, to this plus that gives you x to the 0, e to the x, and then plus, this gets distributed to both parts, x to the negative 1 dx. So this is just like saying, can you integrate e to the x plus x to the negative 1? Both have their own special rules. E to the x, like we said in the last problem, whoops, is its own antiderivative. I was getting ahead of myself. So e to the x. And maybe I was thinking of this next part. This next part has an antiderivative of ln of absolute value of x. And then don't forget your plus c. Okay. You might see a word problem or 2. You're always going to see wording. It might be like number 11 or 12, and you'll see wording in the question that indicates that you're given a derivative, and you have to get backwards. You have to integrate to get to an original function. I think the one we should try is number 12. I think 12 looks a little trickier than number 11 does, so we'll try that together. It says a company estimates that the marginal cost, meaning derivative of cost, of producing X items is this expression in terms of X. So marginal cost, C prime. Cost of producing one item is $562. I can hear myself asking you guys in class, why did we get that fact there? Why are they telling us that one item costs $562? And it must be for us to get C later in the question. And then you have your final thing you're trying to find, the cost of producing 100 items. Well, we need the cost. That means we need a c of x function. And since this is a derivative, we can take the antiderivative to get a cost function. We need the antiderivative of 192 minus 0.002x taken with respect to x. So let's integrate. C of x, the cost, equals, here's a constant, 1.92x, minus, let's take this up a power. X goes up to the second power, but we have to divide the coefficient by 2. So it'd be 0.001 x squared. Did I forget anything? Anything at all? Plus c. So we'll put that on the end. Step 2 must have been why we underlined this part of the sentence here. We need to get C. We need to get this constant. So the cost of producing one item is $5.62. That's your initial condition. We can plug a $5.62 in for the cost when we plug in a 1 for X. So $5.62 equals 1.92 times 1 minus 0.001 times 1 squared plus C. Little calculation gives you that C equals $560 and about 8 cents, 0.081. And that is your constant of integration. Next up, we can plug this C back in to the cost function so we can actually answer the question. So C of x equals 1.92x minus 0.001x squared plus the C that we got, 560. 0.081. Almost ran out of room there. And we want to find C of 100. So last step, C of 100, that goes straight into the calculator, and you're going to get $742.08. And that is your cost of producing 100 units. Check the key for the answers to the rest of these. I wish you guys the best of luck preparing for your indefinite integrals test. And any questions, you guys got to let me know. That was a lot of work. You deserve a little break. Take a page out of my book, maybe grab a Dr. Pepper, and enjoy the rest of your day. All right, see you guys later.